and a warm welcome to the Direction Live Online. Again, I'm Nabila and I am your host for today's session. Now, you have joined us today for a webinar on Cities 4.0, Smarter Urban Planning for the Future. We will be joined by a specialist in Esri, Malaysia, on how we can see the evolution of GIS technology, and also we can use it in planning our future smart city using ArcGIS Urban. Before we get to the details of this topic, allow me to introduce our presenter for today's session. Meet our presenter today, my colleague Afif. He is our industry consultant in enterprise consulting team of Esri Malaysia. So without any further ado, I shall pass this presentation to Afif. Over to you, Afif.
Okay, thank you so much, Nabila. Hello, everyone, and thank you for joining us today. So the first thing that I would like to highlight here today is that our cities are actually facing massive challenges. Cities are complex, dynamic, and interconnected. They need to attract investment, manage housing affordability, improve economic resiliency to meet their sustainability goals, and technology can actually change and shape how we build our cities. So while at the same time, providing the cities the ability to react at the same pace in which things are happening out in the rest of the world. So GIS provide the building blocks, and we, Esri technology, we provide the technology that can actually help to solve some specific challenges that all cities are facing. Okay, so what you are seeing here today is an example from the Boston Planning and Development Agency. So many cities, including this Boston shown here, have for a very long time to actually use the physical 3D models, which have played a key role in providing context on ongoing projects. And what we can actually see here that the model itself is quite detailed, but it's nearly impossible to actually keep it up to date. And then it is not being able to share, especially without being in the same physical space. What I mean is that one actually might create it in a different scale and to actually fit to another building blocks, for example. So this classic way of modeling the built environment, however, can actually be replicated in digital space. Okay. So why we need a more digital and multidisciplinary planning processes? This is where what we see across many of our customers, right, is that they face some common yet complex challenges. So they are looking to lower the cost of recurring plan updates. So I will actually share later on in terms of some of the documentations, and then bring some accountability and transparency towards their goals while also improving access to GIS planning itself. So all of this can actually be summarized by transforming the traditional analog processes into a digital one. So why is this actually important for us here, especially for those of you coming from the local government and also from the urban planning side? So based on the research in the journals of the American Planning Associations, 72%, that's nearly 3/4 of jurisdiction within the 50 largest United States metro areas, do not actually permit higher density development greater than 30 density per acre. So this is actually happening everywhere in Europe. However, in Malaysia, we can actually see that there's a lot of high-rise buildings which easily can actually reach 200 units per acre, and even though some of the areas actually have a capped development capacity of up to 30 to 40 units of single houses, but how do we actually play around with multiple needs of this housing development needs? Okay, so I believe this will actually lead to the quality of life over a certain period. So in terms of traffic congestion, in terms of crime rate, in terms of citizen livelihood, so we need a tool to actually provide a better planning of a development scenario with consideration to cater on this housing supply. Okay. So many of the cities also actually maintain incredibly complex approval processes. Some permits actually require more than 100 approvals, depending on the nature of the buildings. And 50 days. 50 days is the average length of time to issue a standard building permit. While many cities in the survey only track the time it takes to respond to the initial application. So even a lot of cities work through a process of resubmission that can actually last up to a 2 years process. So based on the level of complexity of the project and the amount of paper that actually being passed around in between departments and also external department consultant. So we need to seek a way on how to speed up the process while not compromising the integrity of the reviewing process. So this is actually increasingly becoming important and more challenging. Okay, finally, it all comes down to resources and money. So based on this survey of 65 jurisdictions in California, 300,000. So this one is really different, depending on this one is actually conducted in US. In Malaysia, it might be different, but what I would like to highlight is there's a huge amount of money actually being used to actually conduct any plan update, whether it's a rezoning or inventory updates or any other changes. So in this chart, we can actually see the estimated cost by a private consultant per government agency. This one is actually come from the planning cost guidebook, and it's actually referred to most of the costs that actually occurred in the US. But what I would like to highlight here is that there's a huge amount, and the proportions of amount is mainly on the comprehensive plan, and then there are some on specific plan and zoning code update, and also some actually contributed by the housing element. But the cost here actually not include the staff time that actually being spent by the local government employees. Okay. And most of the time, one of the most important steps in any planning initiative is to update the base data set, so which is usually out of date. And based on the survey, you can actually see that it can actually increase the cost by around 25 to 70%. And this is actually an expensive amount that we can actually avoid if we have a system that can actually keep the base data up to date from time to time. Okay. And another consideration is in terms of public outreach, and it's actually consume 30% of the budget to actually educate people and to engage the community in terms of the new development. Okay. So what you see in the blue portion here is the actual budget needed to actually construct any development. Okay, any plan updates or development. So by having a better base data ready to go and having a more modern and inclusive outreach process, we can actually leave more time or resources to generate more concepts and provide a better analysis. So what we are seeing here, what I would like to actually demonstrate here today is basically cater on the capability of ArcGIS. So this is actually a tool that can provide a more data-driven approach to planning. So it can actually be used to address urban planning challenges that I've actually addressed earlier. So now we will actually go through some of the case studies, some of the success stories that have actually been achieved by some of our users. Okay. According to the director of planning from the State College Guru in the US, there's a lot of potential redevelopment energy that could happen, but it's hard to get people thinking about what they can actually do. So this digital twin tool will be helpful to orient new officials about the issue. So what is actually the Penn State University want to achieve is that they want to actually manage a development within their own campus, and then they want to provide a residency for the students outside of the campus, in which they want to communicate the projects to the local authorities. So using the ArcGIS Urban, they can actually visualize the construction boom in a small area, whether a small portion in their campus or outside of the campus. And then this also actually increase the collaboration between the Penn State University and also their local government. So this is a platform where Penn State University actually draft their projects and then share the projects accessible through via web to the local government, and they can actually communicate with them. So urban model is actually being used as a basis for a comprehensive rezoning in this case. Okay. And then the next use cases that we have here is in terms of digital twin to enhance sustainability. This is actually being done by Uppsala Municipality, Sweden, and they state that we started off thinking the model as a tool of communication. So they want to communicate with the community. When they do a plan rezoning, for example, they want to actually communicate with the nearby community. So this is actually an interactive model for the public consultation, where the public want to actually provide certain inputs to the future development, or public want to actually highlight certain complaints, for example, so they can actually use this tool to do that. So basically from this also they achieve to increase the housing units up to 50% over 30 years in the future. And this also actually cater in terms of their carbon neutral plan, where they actually include certain parks as a part of their parameters within the city model itself. So I think this is actually one of the pioneer in Agest Urban, which is the city of Boston. So based on their senior architect and urban designer, Agest Urban actually helps in guiding their development. So they wanted to actually develop workflows that use metrics and standardized process and procedure to evaluate projects moving forward. So what they actually achieved that they actually provide Agest Urban as a platform for architects to actually download the 3D city models, and then they actually receive 80 new major developments proposals per year, and they actually use ArcGIS Urban also for a 3D submission process for any architectural models, where they have actually incorporated the submissions from 3D models from the architects as a part of their development approval process. So here are some of the key features that I would like to highlight for the ArcGIS Urban. So basically, it is a web-based that one you can actually access anywhere on any desktop, for example, on any let's say you can actually access from tablet, for example, which enables a data-driven urban design by linking regulatory changes with the ability to parametrically model. This one we can actually see later on. So we can actually sketch up build-up scenarios. So within a certain zone that you have actually specified, you can actually sketch up, you can actually reclass the building, for example, for a residential, for the offices, for the retail, you can actually reclass from there. And then we can actually evaluate design with dashboard. So once you make any alteration to your sketch, for example, it will actually be reflected to the dashboard. So you can directly assess what have actually been done on a certain scenario. So you can actually test land use and zoning changes. And this one, in terms of model suitability to identify sites. So for example, you want to let the machine help you in decision making, which area is actually suitable for residential. We can actually put on some parameters, and machine will actually advise you on which area is proper for certain zoning, for example. And then we can also perform interactive spatial analysis. For example, you want to do a shadow analysis, a line of sight analysis, you can also conduct from this ArcGIS Urban platform. So the general workflow overview on how you do things in ArcGIS Urban. First, you actually connect and integrate. So, and then you choose the study area, design and develop scenarios, and share and collaborate. So these are the proportions of things that within the workflow overview, where in terms of connect and integrate data, you can actually use your existing planning system. For example, you can actually extract data from OAC3 Plus, for example, or any of your Kebenaran Merancang system to as a part of the data, and then we choose a study area for certain zoning to actually start to do our planning scenario, and then we design and evaluate scenario. And from here, you can actually share and collaborate internally within your department, or to any other external stakeholders. Okay, so without wasting more time, so let's see on how you can actually apply this ArcGIS Urban to your own work. So how I will actually demonstrate an ArcGIS Urban here. So what you are seeing here is actually a 3D representations of a city. So this is an example of a 3D ArcGIS Urban from the city of Boston, and the colored building that you see here are basically projects. So projects in the context of ArcGIS Urban are small-scale, short-term planning activities, usually 1 or 2 buildings on a parcel. So you can actually see the distribution of the projects in the 3D models here, or you can actually see it by list from the left pane here. So from here also you can actually filter the status of that particular projects. So let's say we want to actually see the ones that is under construction. So these are the lists that are under construction, and let's say I want to actually move into details on these particular projects. You can actually, when you click, you will actually zoom to that particular extent. And from here, we can actually see the locations of that projects. So this is actually the projects that currently under construction. And on the right side here, there's the details of these particular projects. And from here, we can actually see the existing condition of the projects. So let's say I move to the existing condition of the project, we can actually see that there are two high-rise buildings on the side of the project, and this is actually the project area. So basically, this was initially an abandoned parking garage, and now they want to actually redevelop into this square tower. So we can actually see how the model actually fit into the current environments of this particular blocks or area, for example, right? So the next thing that we have here is the indicators. So indicators are actually parameters that are being used to actually assist you in decision making. Okay, so here we have indicators such as the personal crime, diversity, population density. So let's say I want to actually open up the flood hazard risk. So this is where we start to see the flood hazard over the city of Boston. So this is actually the flood hazard area that actually impacted a certain zone, for example, or a certain development project. So you can actually put on, if let's say you have a different scenario with different water depth, for example, historical flood of 5 meter depth or 10 meter depth, you can also include somewhere here, and you can actually be visualized to assist in your planning processes. So the third elements that I would like to show here are plans. So basically, when I click over here at the plans, you can actually see on the map here, we have two pins that actually showing the existing plans in that particular place. So once I actually open up one of the plans, let's say I prepared one of the plans here for us to actually play around. So we will actually show one particular area that you have created a scenario in which actually you are planning to redevelop something. So this is where example here, I would like to actually see the base map as imagery. I can actually change it to imagery, so it will give a better representations over the area. So it will so the imagery will be embedded on top of the schematic. And then you can actually play this one. You can actually use it same as the layer, so you can actually turn it off if you want to actually if you want to have a better view during your alteration process. Okay. So what we have over here are the list. Okay. So what we have over here are some of the modes. So we have the details of a mode in which actually give an explanations of the entire plans. So where the plan is actually located, the durations of the plan. And then here we have the zoning, in which you can actually alter the zoning code, for example, later on for a different scenario. And then we have a development tab in which we will actually do some edit sketch. Because where you want to edit the different spaces, you will do over here. And then we do have a dashboard. Over here, we have a dashboard that actually show all the metrics that are predefined or some customized metric that actually according to your needs. And over here also we have a discussion tab in which maybe you make certain alteration to the plan and you want to actually discuss with let's say from planning department want to communicate with building departments, you can actually discuss on some particular topics here, right? So I've prepared a test scenario here where we can actually play around in terms of alterations of this plan. So when we want to actually do a certain alteration, we go to the development tabs. So over here, we can actually select any plans that you would like to do some alteration. For example, I select the zoning here, and then here we can actually see these are actually the zoning code, the space use code that have actually been assigned. For example, like here we have open space, we have a large portion of residential multifamily over here, and down here we can actually see all of the parameters that actually highlight based on this particular zone. So the floor of the building, the height of the buildings, right? So once I click the edit space here, so basically I can edit the existing scenario that have been created. For example, a planner have actually prepared some of the draft, and then another planner would like to actually edit. You can actually edit here. Let's say I want to actually draw a new surface on top of this building here. So once I click here, and then I want to click a section here. So a new sections will actually appear on top of here. Okay, click okay. Okay, first I click over here and then on the oops, no, sorry, a new surface. Okay, so once I create, I edit I click here. I want to actually recreate these portions of the parcel. So from here, we can start to actually define the space use type. For example, you want to have a retail on top of building, to show why. Maybe we can actually put a retail on top of here. And then you want to actually add more, you want to add more level to it. So we can actually duplicate this part. So we have two levels of retails over here. So as you can see, once we add more retails over here, the space use selected panels here actually change according to the drawing that you have made. So we can see about 3,800 meters square over here. Once we add on, so we have additional retails added up on top of the building. So now all the parameters actually changes based on the input that you've made. Okay, and then this is where you actually make edits on the existing building, for example. But if let's say you want to actually edit on top of a drawing, and you want to actually draw it from scratch, let's say I put it into schematic for better representation. So this is actually not included as part of the plan, and you want to actually start from scratch. So we can start to actually demolish this building. So once I select the parcel here, I can start to demolish the building here. So I would like to demolish this custom area. So once I demolish, the area will actually be demolished, and you can actually start from scratch to actually draw on top of this zoning, for example. Okay, to start from scratch, we select the zone and then we edit the spaces here. So from here, we can start building a new building, for example. So let's say I draw an L-shaped building here. And then let's say I want to add on a wing to this section. So you can actually do by scratch for this. You don't have to actually use an existing 3D building. You can actually start from scratch from here. Okay. So when we've done with this part, so basically we've done with the alterations of the sketching, you want to actually visualize in terms of the dashboard that we have here. So as you see here, basically once we let's say I move forward into a full build-up area, we can actually see all the parameters actually dynamically change based on the selections of the certain zone. So you can actually see all of this residential, for example, the calculation that actually being used for it, and then how much is the residential units over the area, how much is the residential population, how much jobs actually being created over this particular zone, for example. And if let's say I click over one of the zone here, you will actually only listed all the parameters that actually contributed by that particular zone. Okay, by that particular zone. Okay. And let's go to one of the advanced topics here. If let's say you have a certain custom criteria, so this one might actually not catering some of your needs. Some of you might actually interested in terms of traffic management, for example. So how you can actually add on to the existing metrics. So we go to the configure plan, and from here, this one quite an advanced topic, whereby you can actually create your own custom metrics for your own dashboard. Okay. So from here, we go to see. Okay. So basically, this is a dependency matrix. This one might quite intimidating, but actually it's quite simple. It's quite straightforward. Basically, this is where you want to actually create a dependency. So let's say I would like to add another criteria in my dashboard. For example, I name it as a number of vehicles. Okay. And then I want to create a dependency from the number of vehicles. I need to connect the number of vehicles to, let's say, for example, one house might actually contribute to 2 cars, for example. So, based on the residential units, I would like to actually provide that value to the number of vehicles. So, from the connection here, we can start to actually provide a calculation to actually contribute to that particular. So we want to actually, for every residential unit, I want to actually have 2 cars being counted as part of the parameters. So I put the weighting here. So once I've done with this connection, go back to our scenario and we'll review the dashboard that have actually being updated. So as you can see here, we now have the number of vehicles as part of the dashboard. So you can actually customize the metric that you are actually interested in. And from here also you can actually edit the dashboard. So let's say you want to rearrange this, you can actually rearrange. And then let's say you want to actually add on certain, let's say I want to add certain symbols here. So it's up to your own preferences. Okay. So once you have actually customized all of these dashboard parameters, you can actually download all of these dashboard parameters information. So once I click the download here, you will actually download an Excel file that will actually show all the parameters for a different scenario, and also for different types of metrics that you presented. So for example here, now we are actually viewing on the full bill out. So all of these parameters you can actually make use in terms of your calculation or your reporting purposes. And then another thing that I would like to share here today is in terms of analysis. So one of the things that we also have inside of our GIS Urban is in terms of analysis. So these are basic distance measurements, measure area. So for line of sight, once you click the line of sight, we can actually specify, for example, right, from this building, whether this particular window will actually have visibility over the park over here, for example. So we can actually see there's a distinction between the green line and the red line. It means that over the red area, the window cannot actually see that particular park, for example. So this is actually useful for CCTV placement, for example. You want to actually put a certain CCTV and see where's the visibility actually covers, for example. Right? Another type of analysis that we have here is in terms of profiling. So from here, let's say I click a starting point here, the area over here, so we can actually see the elevation profile. So maybe you want to actually incorporate in terms of slope analysis over the particular plan. You want to actually see the height of the building as compared to the ground. So you see the green line is basically the ground, and the orange line is basically representing the buildings and also the surface. So this is where you can actually make use of this tool. Another thing that we have here is in terms of shadow cast analysis. So in case of whereby you want to actually find the best place to actually put a solar panel on top of the building, for example. So we want to actually, say I want to see the total shadow durations. Over here, we can actually see from a different time and also from a different dates of the year. So you can actually assess which area that actually being shadowed by which building are actually being covered by shadow, for example. So certain area might not have any shadow, but over this area we can actually see a higher intensity shadow. So this is not a good place to actually place a solar panel. So you can actually identify from this kind of analysis. Okay, so back to the slides. I think I've come to the end of the demonstrations. So over here also I've shared some of the resources that you can actually learn more in terms of RGS. Some of the demonstrations that we created, and then some of the blogs in terms of what's new in RGS Urban. And then I also have actually attached some of the case study earlier, so you can actually refer to them. So I think that's all from me. So I will hand over back to Nabila to wrap up the session.
Thank you, Afif. That was a very interesting topic on the RGS Urban, on how we can plan our city in the future. Okay, so we move to the first question. Okay, we have here. The question is, do I need to have a 3D base map to get started with RGS Urban? So over to you, Afif.
Okay, thank you for the question. So basically, it is not essential to have 3D models, but it is preferably for you to have it. But as you've seen earlier in my demonstration, you can actually start from scratch. You can actually create your own 3D model from there. But if you have your own, like for example, like building footprints, you can actually extract from there, and that can actually be a minimum requirements for the RGS Urban. I hope that's answered your question.
Okay, so what's the difference between RGS Urban and RGS Geoplanner? So over to you, Afif.
A good question. For those who have actually been working or maybe seen some demonstrations on geoplanning. So basically, geoplanning are designed for 2D context. So this is designed for regional planning on 2D context. But RGS Urban has actually provide a deeper context in terms of how you can actually adjust your metrics, on how you can actually plan on different scenario on 3D environments. So that's the differentiator between geoplanning and also an RGS. But I hope that's answered the question.
Okay. The next question we have, besides planning department, can other local government department benefit from using RGS Urban?
Okay. So I've mentioned in the earlier part of my slides that how we want to actually include a multidisciplinary approach to this urban plan. It's not just for planners. So basically, that's what you've done in your merancang process, for example. There's a lot of department actually involved. So you can also actually make use of RGS Urban to do project monitoring. Example. So let's say we have a particular project and you want to actually monitor the progress of that project, we can actually make use of Urban as an indicator for that. And then this will also be beneficial for finance, for example, when you want to actually verify a certain project status to the payment progress, for example. So another example is, for example, like the property management. You can actually visualize where's the Malaysia property, for example, and then any construction projects that are being done on that particular property, for example. So that is more on the project monitoring side. Actually, we are actually looking forward into some of other use cases to actually make use of RGS Urban for the local government.
So the question sounds, let's say I want to do a flood analysis or simulation. Can I customize the parameters? Over to you, Afif.
Okay, good question. So basically what I've shown just now is actually a ready layer for flood. So if let's say you want to have a flood analysis or flood simulation, we do have this application, which is an RGS Pro, which is more into a data preparation stage. So that is where you want to actually do a certain flood analysis. You have an elevation data, for example, and then you want to actually simulate a certain flood conditions. When you have simulated the data, then RGS Urban actually being used to consume the simulated data. So basically, RGS Urban are not being used to actually simulate any flood analysis on top of the platform. But the data are actually being prepared from RGS Pro to be consumed by RGS Urban. I hope that's answered the questions.
All right. Okay. So thank you, Afif, again. All right. I think that's all the time that we have today. Okay, so if we haven't answered your question yet, we surely reach out to you back soon. So thanks for joining us today. Thank you, Afif. And we look forward to seeing you again for the next webinar.
Thank you, everyone.
Bye.